time signal. Okay, here a problem it is given. Consider a continuous time LTI system with the unit impulse response, that is h of t is equal to u of t, and input x of t is going to be e raised to minus at u of t, where a is greater than 0. Find the output y of t of the system. Solution: y of t is going to be x of t convolved with h of t. Then y of t is going to be, in terms of continuous means it is of integration, right? Integral sum. Okay, for that reason minus infinity to plus infinity x of tau h of t minus tau into d tau. Next, this is first signal x of t, it is given as e raised to minus at u. This is an exponentially increasing function. We already come across this, right? Based on that, what I can write, because a value is in negative way, okay, for that reason it is exponentially decaying function, decreasing function. Okay, if it is given as e raised to at means it is increasing function. Okay, here it is minus at, for that reason it is decreasing function. Then what about our h of t? It's of u of t. We know that what is u of t? From 0 to infinity it will be 1 only. This is our h of t signal and this is our x of t signal. Next.
ನಂದು ಮೇಕೆ ಅಟೆಂಡ್ ಮಾಡೋಣ, ನಂದು ಮೇಕೆ ಅಟೆಂಡ್ ಮಾಡು ಅಲ್ಲಣ್ಣ.
Okay, to plot x of tau, and in the previous case we changing from n to k, but here we have to change from t to tau. Okay, for that reason to plot h of tau, x of tau and h of t minus tau with t is equals to 0. In the previous case n is going to be taken as 0. Okay, then changing for t wherever it is there, we are replacing with tau. That's what x of tau e raised to minus a tau u of tau. Then here for h of t signal we taken in the at tau is equals to 0, t is equals to 0, you'll be getting as minus tau, right? Minus tau means the reflection of the x of t signal, you'll be getting as like this, reflection of the u of t signal. At 0, t at tau is going to be equals to t only. Okay, then when t is less than 0, when t is less than 0, is there any signal here? X of tau, h of t minus tau is going to be 0 only. Therefore, y of t is also going to be 0. When t is greater than or equal to 0, from 0 to t, it will be, it is having, the signal is going to be existed here, existing. Okay, for that reason y of t is going to be, it is, don't know for which value it is going to be ending, right? We don't know. It's always continuous. Here it is also, it is always continuous only. Don't know at infinity range it will be reaching, but you should not take infinite only. Okay, we'll considering that our signal is going to be exist means losing at a t value. For that reason the limit is changing from 0 to t, x of tau, h of t minus tau d tau. Then what is our x of tau? X of tau is nothing but e raised to minus a tau u tau. That's what u tau is always 1. Remember, u of t, u of n, the amplitude values are always 1 only. For that reason directly taken as e raised to minus a into tau into h of t minus tau is of what? It's always 1 only. Amplitude is always 1. For that reason 1 into d tau. If we solve for this, what is the integration of e raised to minus a tau? It's going to be e raised to minus a tau divided by this, what it is there, that is minus at a. Okay, and limit is from 0 to t. If I substitute here, you'll be getting as, this is constant, 1 by a is taken outside, then e raised to minus a t is minus 0 will get, e raised to 0 is nothing but 1, right? Minus of minus is going to be plus. For that reason 1 minus e raised to minus at you will be getting. I hope you understood what I told. Okay. Then this is what the signal we got. Then we have to plot for the signal. Y of t is going to be 1 by a 1 minus e raised to minus at into u of t. Okay, u of t signal is the constant. That signal is we have to multiply here. U of t. Then when I substitute for the value for t value from 0, 1, 2, 3, if I going on substituting, you will be getting the signal like this. Okay, it is increasing and it remains constant after reaching the value from 1 by a. This uh, difference what I am showing, it is the value for 1 by a signal. Okay, you just remember here how to you will be getting off for this signal. Okay, or else you can substitute for the values for t 0, 1, 2, 3, 4 with some constant values for a, fix that and you can draw, or else this will be the amplitude, right? 1 by a will be the amplitude. Based on directly you can draw this signal. This is what, and this is very important, it is asked in the exam for 8 marks or else 6 marks, it is fixed. Okay, they may give for 8 marks or 6 marks because in question it depends on the question paper how they will be asking. Okay, this is one problem. And next problem it is, consider a LTI system with the unit impulse response. H of t is going to be e raised to minus t u of t. If the input applied to this system, that is x of t is going to be e raised to minus 3t into u of t minus u of t minus 2. Find the output y of t of the system. First we will draw for the u of t and u of t minus 2. What it's going for? Observe here, I drawn here. This is our u of t signal, right? Then this is our u of t minus 2 signal. Means the signal is shifted by 2 position towards the right side. Then I have to subtract these two. When I am done that, I'll be getting like this signal. From 0 to 2, our signal is going to be existing. It's like a square pulse you will be getting as. That is u of t minus u of t minus 2. Okay. Then what about e raised to minus 3t? It's always a decaying function. From a maximum amplitude will be 1. From 1 it is going on decreasing. Okay, you will be getting like this. When I multiply our u of t minus u of t minus 2 with the e raised to minus 3t, okay, I will be getting as, this is our x of t, what you will be getting. Beyond this it is will be 0 only, right? 0 into anything you will be getting as 0 only. For that reason after 2 you will not get any signal. From 0 to 2 you will be getting a 0 to 2. Here it will be 1 only. Here it is decaying function. For that reason it will remains 1 into anything. If you multiply you will be getting as the same value what you are going to multiply. Okay, for that reason 0 to 1 it is same and it is decreasing up to 2. This is what your x of t signal. Then what about h of t signal? It is also e raised to minus t. Minus means it is decreasing function. So from 1 it is always decreasing. That you have to take as e raised to minus t u of t signal. This is our signal. We drawn for h of t and also for the x of t signal. Then we know that our y of t is going to be x of t convolution with h of t. Then y of t is going to be integration from minus infinity to plus infinity x of tau h of t minus tau into d tau. Then what you have to do? Replace t by tau, right? If I replaced, I'll be getting as, instead t it is going to be changing to tau. Then x of tau, instead t it's going to be taken as x of tau is equals to e raised to minus 3 tau. Okay, then the same for h of tau. For h of t minus tau is going to be e raised to, wherever t is there it's going to be taken as t minus tau. Okay, then take the mirror image. Here for this signal, which one is simple? For that signal you take the mirror image. Okay, therefore from 0 to 1 it will be same. Okay, then take the mirror image of this signal. When it is going to be taken mirror image? When t is going to be 0. Okay, for that condition only. At 0, tau is going to be equals to t. Then what are the conditions we have to take? When it is less than 0, nothing signal is going to exist. When it is from 0 to 2, a signal is going to be existing, and again beyond 2. Three limits we have to take. Observe, based on this original signal you observe. Okay, beyond 2 also some signals are there. Okay, that also we have to consider. First condition, when t is less than 0, we don't have any signal here, right? I'm just telling in terms of a graph. Okay, x of tau, h of t minus tau is going to be 0. Then y of t is going to be, of course it will be going for 0 only when t is less than 0. When t is greater than 0 and t is less than 2, means t in between 0 and 2. You can write this condition, or else directly you can write this condition. Which one is easy for you? Go through that. Then y of t is going to be, x of t is nothing but e raised to minus 3 tau. X of x of tau is nothing but e raised to minus 3 tau. In terms of tau you have to substitute, right? Then what about our h of t minus tau? It's nothing but e raised to minus t minus tau. I substituted here e raised to minus t minus tau into d tau. Then observe here, limit is 0 to t only. Okay, then if I solve for this, I will be getting as, I hope you can do of this solving and all, e raised to minus t minus 2 tau into d tau you will be getting. Then e raised to minus t is of a constant value, so I taken out here. What's remaining? Integration 0 to t e raised to minus 2 tau into d tau. After solving this, you will be getting as, sorry, we have to apply the integration here. If you apply, what you will getting? E raised to minus 2 tau divided by, this is the constant value, right? For it is divided by minus 2 with the limit 0 to t. Then substitute for the limit. After a substitution, you will be getting as e raised to minus t divided by minus 2 e raised to minus 2t minus 1. This, if I multiply with this 1 with the, here, I will be getting as 1 by 2 minus of minus plus 1 minus e raised to minus 2t e raised to minus t. This I wrote at last. This is for the condition when t is 0 to 2. When t is greater than 2, so the limit is changing for at that point only, means 0 to 2 only. Therefore, substitute for e raised to, same, the procedure will remain same up to this. Limit only changing, right? What you will be getting? You will be getting up to this, it will be same. Only limit applying, it will be changing. So apply the limit as 0 to 2 only. After applying, you will be getting as e raised to minus t e raised to minus 4, 2 into 2 4 divided by minus 2 plus 1 by 2. Minus of minus is going to be plus for that reason. Okay, if I take 1 by 2 as common, so I'll be getting as 1 by 2 1 minus e raised to minus 4, because here is minus 2, right? In both the condition 1 by 2 is common for the reason. E raised to minus t will be getting. Then brief out of all the answers once. Y of t is going to be 0 when t is less than 0, and it will be equal to 1 by 2 1 minus e raised to 2t e raised to minus t when it is in between 0 to 2. When exactly at when t is greater than 2, you will be getting as 1 by 2 1 minus e raised to minus 4 into e raised to minus t. Okay, at t is greater than 2 only. Then when it is t is equals to 2, you will be getting the signal like this. It is varying up to 2, at 2, then it is decreasing, and the value for at 2, it is going to be taken as e raised to minus 2 minus e raised to minus 6 divided by 2. That is what the signal you will be getting. This is also very important. It is also asked in the exam for 8 hour 6 marks. Okay, definitely asking question. Then one more problem, that is next problem is of evaluate the following time convolution integral, that is y of t is given as u of t plus 1 convolved with u of t minus 2. When it is given like that, first you consider, that is let x1 of t is going to be u of t plus 1 and x2 of t is going to be u of t minus 2. First we will draw for the u of t plus 1. It is shifted by one position towards the left side, right? So minus 1 it will be starting and till infinity it will be 1 only. For x of 2 signal, the signal is shifted towards 2 position towards the right side. This is you will be getting. Then y of t is going to be x of u of t plus 1 convolved with u of t minus 2, or else this is x1 of t convolved with x2 of t. That is y of t is going to be integration minus infinity to plus infinity x1 of tau x2 of t minus tau into d tau. Then what you have to do? Replace t by tau. So after replacing you will be getting as this signal. Only change is you have to replace t by tau only, that's it, right? Then for second signal, at the 0 position it has to reflect the signal at t is equal to 0, means x2 of minus tau will get. For that reason it is we take the mirror image of the x2 of t signal. So we will be getting the at t is equals to tau, means it will be at 0th position. At minus 2th position means tau is going to be equals to t minus 2. When it is t is equal to 0 means it will be times minus 2. For that reason, then for the condition when the t signal is less than 1, when t is less than 1, is there any signal here? It's not having any signal. For this signal also it is not having any signal. So x1 of tau into x2 of t minus tau is going to be 0. Y of t is going to be 0 when the t is less than 1. When t is greater than or equal to 1, what's going for? It is starting from minus 1 till this condition, minus 1 to t minus 2, minus 1 to t minus 2, x1 of tau x2 of t minus tau d tau. Substitute for x1 of tau is going to always amplitude for both the x1 and x2 signals are 1 only, 1.1 only d tau. What you will be getting after integration? You will be getting as t minus 1. Do this integration, you will be getting as t minus 1 only. Okay, then y of t is going to be t minus 1 when our t is greater than or equal to 1. Therefore our y of t is going to be t minus 1 into u of t minus 1. How to take this parameter? Which one is not changed? Which one you didn't take as the mirror image? That you have to reflect here. Okay, when I substitute for the values for t, for t, for when I substitute for t as 0, minus 1 you will get. It's not going to considering here, because our u of t signal is not going to exist for the minus values, right? For that reason we will start with substituting for t is equals to 1. When t is equals to 1, 1 minus 1 it will be 0, right? And u of t minus 1 from 1 it will be increasing function. U of t minus 1 is always 1 only. Okay, just you have to focus on for these values. When I substitute for t is equals to 2, 2 minus 1, 1 you will get. When t is equal to 3, at you will get as 2, and it's going on increasing. This is what you have to draw like this. That is y of t signal, output signal. This is very important. Output signal only in the exam it will be fixed for 2 marks. How we will be drawing, and remaining all part 4 marks or else 6 marks. If it is of marks it is given. Okay, like that it will be given. These are all about the problems based on continuous and also discrete time function for the LTI system. All the problems are very important. Just to follow the procedure how we are going to solve these problems.